All right, here we go. Let's finish up. I should have put B on there. Let's do it right now because this is the second. This will work. There we go. So this is part B. So what did we do yesterday? We found some missing what? Got to change my writing thing now since I changed that. What did we do on 12.2? Well, we did it yesterday, and you were here, so. All right, here. I'm just going to go right to the example and show you how to do this with the example, okay? Yeah, let's just start with the example. There's a couple things that I've written down before the example, but I will show you within the example. So example 3 is the one we're doing now. So we were able to find, if I gave you one angle of a right triangle and one side, you should be able to find all the other missing stuff, right? So if I give you one angle of a right triangle, how do you find the other angle? Very simply. Yeah, you just take it away from 90, and then you got the other angle. That was simple. You didn't need any trig to do that, okay? But then, what if I just gave you one side of the right triangle? Before yesterday, you would never have been able to find the other two sides. Okay, you would have needed two sides of a right triangle. Then you could have used what? If I give you two sides of a right triangle, you could always use what? Pythagorean theorem to find the third side. Okay, but if I only give you one side of a right triangle, before doing trig, you wouldn't be able to find the other two sides. Understand that? All right, but now we know trig, okay? Now, if I find one of those acute angles in that right triangle, if I know one of those angles, I can find the other two sides. Now, what we're going to do is, what if I don't know any of the two acute angles in the right triangle? What if I just know the right angle? But I do know two sides, all right? I got two unknown angles, but I know two sides, okay? Again, before today, you wouldn't be able to find either one of those angles. But now, we're going to be able to. I bet you're so excited, aren't you? I can tell. So, let's draw a right triangle. And I'm going to give you two sides of the right triangle. So what did I just say earlier, just about a minute ago? If I give you two sides of the right triangle, you should be able to find what? The other side. Okay? Without doing any trig. So right here, here's what I gave you. And what I'm going to do, we'll call this A, B, C. All right? So with this information today, right this minute, there's no way that you can find angle A and angle B. Okay? But in about 5 minutes from now, you'll be able to find it, okay, A and B. Now, we should be able to find AC right now. And we can do that in our head. What is it? It's 4, right, because it's a 3, 4, 5 triangle, all right? If you didn't realize that, which you should realize it, if you don't realize it, you should probably go back to Algebra 1. But if you didn't realize that this was a 4 just by looking at it, what could you have done? Pythagorean theorem. You could have gone 3 squared plus whatever, x squared equals 5 squared. Do the math, and you come out to 4. Everybody got it? All right. But it is a Pythagorean triple, so it came out nice and easy. So now what we're going to do is we're going to solve for A, and we're going to solve for B. So I'm going to use the trig. Yeah. I don't know. We'll see how it goes. Let's solve for A. Let's just solve for A. I could have solved for B. I decided to solve for A. No particular reason, just did. All right. I don't know. When I have a right triangle like this, usually the one down here at the bottom is the one I usually solve for. I don't know why. It just kind of seemed like that's the one that in the book they always solve for first. All right. So that's what I'm going to do. So we'll just call it A. I'm not going to make it theta or anything. We'll just call it A. Is that all right? So what we're going to do, I know all three sides of my triangle now. All right. So I can use any of my trig functions, any of the three that we've learned, sine, cosine, tangent. I can use any of them. It doesn't matter. All right. I'll show you why. I'm going to set up all three and just show you. I think I'm going to do this with all three of them and show you're going to get the same answer. Doesn't matter which trig function you use. Right? If you know all three sides. You with me? So let's do it. Let's go the sine. Now you don't have to do all three of these. If this is a homework problem or a quiz or a test, do not do all three of them. Just pick one of them and just do one of them. All right? I'm just doing it just to show you that it doesn't matter which one you use. Which I think this is kind of interesting. Won't be doing this for every single one that we do, but for these I will. All right. So what is the sine of A? Well, first of all, as far as opposite, adjacent, hypotenuse, which one is sine? Opposite over hypotenuse. So here's angle A. Which one is the opposite of angle A? 3. Which one is the hypotenuse? 5. So I could use that one. All right. And I could just use this. I'll show you how to use it in just a minute. Okay, but let's set up the other ones too. What if I wanted to use the cosine? It's what over what? Adjacent over hypotenuse, right? Okay, so what is it? 4 over 5. So cosine of A is equal to 4 over 5. And then the tangent of A, it's opposite over adjacent. So what's the opposite? 3 over the hypotenuse. I'm sorry, not 5. 3 over what? 4, because that's the adjacent. Everybody see that? Look, we got 3 different ratios, don't we? And we have 3 different trig functions. All right? But every single one of these is going to work out to the same exact answer. All right? Isn't that crazy? All right? So here we go. Here's how you solve for A. You remember what we did in algebra? If I wanted to solve for a variable, if I had like this, if I had 3x equals 12, how would I get x by itself? Divide. Why do I divide? Because I do the inverse or opposite, okay? The inverse is a good word, okay? I like that because that's the word we're going to use right here. Use the inverse operation. What's the inverse of multiplying? It's dividing, okay? So what we're going to do over here, now this sign, that's not a variable, okay? It's not a number, okay? A is a number. It represents a number. It represents an angle, okay? So I'm not going to divide by the sign. I can't do that because sign is just a word that represents a fraction. It represents a ratio of a fraction, okay? A ratio of 2 sides, I should say. Not a ratio of a fraction, because that's the same thing. So what I'm going to do is take the inverse of the sign. I'm not going to divide by the sign. This is not sine times A. Everybody hear me on that? That's very important. It's not sine times A. It's the sine of A, which means I'm going to take angle A, and I'm going to take a ratio of the opposite to the hypotenuse. That's what sine means. So I can't divide by the sign, but I can take the inverse. Let's go back in time a little bit. I don't know if you did this in Algebra 1 or not, but I'm going to show you right now. What if I had something like this, x to the negative first? Have you seen that? Have you seen negative exponents? Did you do that in Algebra 1? Negative exponents? Okay. A negative exponent basically means you're going to do this. You're going to take 1 over x. This and this mean the exact same thing. Zion, you getting this? Because this is really important. We're getting right to the crux of the matter. You started sleeping right when it gets important. So this means the inverse. So what does this mean? That means the inverse of x. If I said, what's the inverse of 3? What's the inverse of 3? It's not negative 3, no. It's the inverse, which means the reciprocal. What's the reciprocal of 3? 1 over 3. What's the inverse or the reciprocal of 17? It's 1 over 17. What's the inverse of 3 halves? What is it? 2 over 3. Okay, you just flip everything. Everybody got it? So what does this mean? This means the inverse of x. You follow me? All right, so what we're going to do is we want to get A by itself. So what we're going to do is we are going to take the inverse of the sign. And what is the inverse? When you do algebra, what does the inverse do? It cancels stuff out, doesn't it? Okay, if I took the inverse operation of multiplication, it's division. What did that do? That canceled it out, right? And whatever we did to one side, we had to what? Do to the other side, okay? So what we're going to do is we're going to take the inverse of this. This is how we do it. We write sine to the negative first. Why do we write that? Because that's what it means. When you take something to the negative first power, it means to take the inverse or the reciprocal of it, okay? You understand where that symbol comes from? We're going to use that symbol a lot, so you need to understand like where it comes from. So I'm taking the inverse sine of the sine. What do you think that does to the sine? Cancels it out. That's right. So this and this cancel each other out. And what am I left with? I'm left with A. But I can't just do it to the left side. What do I have to do? I have to do it to the right side. So I got to take the inverse sine of what? 3 over 5. It looks weird, looks a little creepy at first, Okay, but after you get used to it, it's not that big of a deal. It just means we're taking the inverse sine. So I am not putting in the sine of 3/5. I'm putting in the what? The inverse sine of 3/5. I'll pull the calculator out here in a second. Let's get that. Again, if you're watching this on YouTube, you won't be able to see this. So sorry. I should figure out how to get this to show up on this recording, and I've done it before, but I just don't want to take the middle of class to do that right now. So anyway, first thing I get, what do I have to do with this calculator every single time? It's ridiculous, but I got to change it to degrees. So I change it from radians. Radians is something we probably won't talk about this year, but in Algebra 2, you should talk about radians. So I'm going to change it to degrees. All right, everybody good? All right, I'll clear it. So now I'm in degrees. Now I should be good. So here's what I'm going to do. The inverse sine, sine to the negative first. I know it's kind of small, but if you look over here, excuse me, to sine, right above it in yellow, you see it right there? It's hard to see, but if you look on your calculator, you'll probably see it. All right, it's sine to the negative first. That's the inverse sine right there. So how do I get to that yellow one? Second function, that's right. So I'm going to hit second function, sine. See how it puts it on the calculator, sine to the negative first? And now what am I going to put in? 3/5, or 3 divided by 5. I like to close the parentheses just to make it look nice and neat. And now I just hit enter, and that's an angle right there. What is the angle? 36. Let's go one decimal place. 36.9. So 36.9 degrees, and that's the angle right there. 36.9 degrees. So I just found, let's move this over. I just found this angle right there. 36.9 degrees. That's that angle. Yeah, technically yes. I was a little lazy, but you're right. I should put approximately. But if I stick it in here, I'm just going to write 36.9 right there. Now, how would I find this angle up here? Yeah, I would just go 90 minus 36.9. All right? So let's just do it right here. So 90 minus 36.9. All right, 53.1. I probably could have done that in my head. 53.1 degrees. All right? So that's how you can find all the sides of that triangle. Since I did all three of these, let's just do this for fun now. All right? Do you see how I did sine to the negative first, the inverse sine, right? After a while, and we've only done it once, and that's a while, okay? Do you really need to do that? No, because you know the sine's going to cancel out, but you just have to know to do what? Take the inverse sine of what? The other side, okay? So you don't have to do this step right here. I did it for the first time so you see what we were doing, okay? So like right here. So what is A equal to right there? Well, I'm going to take the inverse sine, or the inverse cosine, right? Which means the cosine will what? Cancel out, but I also have to take the inverse cosine of the other side. So I'm going to go inverse cosine of 4/5. Now, this is where it's kind of cool, because you're like, how in the world could that possibly be the same number? But it is, all right? So we'll see. Hopefully it works. Inverse cosine, so second function cosine of 4/5. So it's 4 divided by 5. I like to close the parentheses just to make sure. And look at that. Same exact number all the way to the last decimal. Same exact thing. Do you agree? So what am I going to do with the tangent? Yep. Second function what? Tangent of 4/5 this time. Different fractions every time, right? So 4/5. And what do you think it's going to be? Oh, it's 3/4. I was looking at the wrong one. No wonder it's a wrong number. Let's try it again. Second function tangent of 3/4. 3/4. And there it is. That's the same number. Exactly the same. So it doesn't matter which trig function that you use. Let's just slide this over. Doesn't matter which trig function that you use, you're still going to get the same exact answer for that. Okay? See that 53.1? Let's say we wanted to find that 53.1 by doing trig and not just subtracting from 90. Let's see if it really works. Okay? Again, you don't have to do this on a quiz or a test. Do it the quickest, easiest way that you can do it. Okay? I'm just trying to teach you stuff right here. So let's say we're trying to find this angle right there without subtracting this from 90. All right? That was definitely the easiest way on a quiz or a test. Once you find one angle and you need to find the other one, absolutely on a quiz or a test or a homework, subtract it from 90. That's the best way to do it, okay? I'm just showing you this because I just want to show you that it works as well. Remember what that answer was, 53.1? Okay, so let's do it. So let's solve for B. What's your favorite trig function? Do you have a favorite yet? Sine, cosine, tangent? You like cosine? All right, we'll use cosine. So we're going to do the cosine of what this time? What angle this time? B. We're going to find this angle right there, cosine of B. So what's the thing? It's adjacent over hypotenuse, correct? Which one is adjacent to angle B? 3. Which one's the hypotenuse? 5. All right? So now let's bring this calculator back. And this time we're doing what? How would I write this out? I'll tell you what. Let's oops. There we go. How would I get B by itself? B is equal to what? How do I write it? Cosine. Yeah, let's say the inverse of the cosine. Okay, inverse cosine of what? 3 over 5. See how easy that is? Again, it looks kind of weird, doesn't it? Because that negative exponent, but we know what it means now. It shouldn't be that big of a deal. All right, so now let's put that in there. Why did I put an H right there? I don't know. Let's just clear that. There we go. All right, so what am I going to do? Second function, cosine of 3/5. 3 over 5. And then let's see what we get. There it is, 53.1, just like it should be. Isn't that cool? I think it is, right? You found it kind of two different ways, didn't you? Right? Subtracting from 90 or doing the trig. So you could do that either way. Everybody good? If I wanted to, I could have done it by the sine. I could have done it by the tangent. We've already seen it once, so we don't have to do it again. That it would work anyway. So it's pretty cool, I think. I don't know how excited you are about it, but I like it. All right, let's see what else we got. Example 4. Now, we're going to do this the most efficient, the quickest way that we can. I'm not going to go through all that mess that we did. Seems like it would take forever to do one of these problems if you did what I did every single time. And you're right, it would. It would take a long time. But now this one's not going to be quite as pretty. Why was the other one kind of pretty? Because it was a what kind of a triangle? 3, 4, 5 triangle, okay? So this one, it's a little bit of work. So that's 11, that's 17. This is A, C, and B. All right, so we want to find all the missing parts. I want to find, what are my missing parts, by the way? Hypotenuse. Then I want to find angle A and angle B. All right, so really we only have to do trig one time, don't we? All right, just to find one of the angles. Because I can do Pythagorean theorem to find the hypotenuse, right? And once I get one of the angles with trig, all I got to do is take it away from 90 to get the other one. So really, in this triangle, I'm finding 3 things. Only one of them do you have to use trig for. Everybody got that? Let's do the Pythagorean theorem. I'm not going to do the Pythagorean theorem. You know Pythagorean theorem, okay? I'm not going to do the whole step. I'm just going to tell you what it is. Okay, if you do Pythagorean theorem, it comes out to the square root of 410, but they're allowing you to write it as a decimal. I'll put approximate. We'll go 1 decimal place, and it's 20.2. Everybody good with that? Now remember, this is an approximate value. 11 and 17 are exact values. So if I wanted to, what do you want to, let's do A first, since it's first in the alphabet. All right, I'll do A. So remember before I said if you know the 3 sides, you can use any of the trig functions. It doesn't matter. But, Simone, you watching? So I don't want to use the hypotenuse, though. Why not? Because it's a what? It's an approximation, okay? And I want to be as exact as I can, right? Now, if you wanted to use 410 or the square root of 410, that would be fine because that's an exact answer, okay? But don't use an approximation because we rounded this, okay? So just let's use 11 and 17. So which trig function am I going to use if I only use 11 and 17? Tangent, good. It's opposite over adjacent. So let's write that down. So it's the tangent of A. Remember, I say show work all the time, right? This is what I would want you to do. What I'm doing right here. Now, of course, here I didn't show the work. You should show the Pythagorean theorem, all right, and work it all out. I'm just did that to save some time. But here's what you would do for the trig. You go tangent of A equals opposite over adjacent. Which one's opposite? 17. Which one's adjacent? 11. So now we can solve for A, and I want you to write this down, okay? A equals what? The inverse tangent of 17 over 11. And don't do this. Don't put 17 over 11, round it, and then take the inverse tangent of it. Okay, do all of that in your calculator. So let's bring the calculator over here. Don't know why that keeps... I must be clicking something to make... Oh, I know why I did that. Because, anyway, it doesn't matter. All right, let's do it. So it's second function tangent of 17 over 11. 17 over 11. Close the parentheses. There we go. So it's about 57 point what? 1. Yeah, because that 9 rounds that 0 up to a 1. So we'll go 57.1. And that's this angle right there. 57.1 degrees. Again, it's approximate, but that's okay. We're rounding these anyway. How could I find angle B? Very easily. What's the easiest way? Yeah, go 90 minus 57.1, and that's 32.9. It's that easy. It's pretty simple, isn't it? All right. Before today, there's no way you could have found either one of those angles. But now that you know your trig functions, now you can find those angles. Okay? All right, let me talk about this really quick. I only have like 5 minutes, but I think that might be all it takes. All right. So I'm going to talk about two things. This is kind of where this works practically. All right, it's called angle of elevation and depression. Okay, elevation, elevate, to go up. Okay, depression, to go what? To go down. Okay, so here's the situation. I'll just kind of hand draw this for you. So let's say you're on a cliff, all right? There's the cliff right there, and this is the top of the cliff. There's you. Boom, boom, boom. All right? You're going to jump off the cliff. No, you're not jumping. You're just looking, okay? And let's say this is a lake or an ocean or a river or something like that, okay? And you saw a boat. Here's my boat. Boom, boom. And we'll make it a sailboat. There's my sailboat, okay? So what we're doing here is there's an angle that we're looking at, all right? And so I tell you what, you could go eyeball. I'm just going to go from the feet to the bottom of the boat right here. Is that all right? So look. So it's kind of like your line of sight. I should go from the eyeball, but that's okay. I just want to make a nice triangle out of it. So from there to there, that's your line of sight, from here to here. So where is the angle of elevation and where is the angle of depression? Well, I'm glad you asked because I'm about to tell you. So you see that yellow line right there? That would be horizontal, okay? It'd be parallel to this. Everybody see that? So this line is parallel to this down here. If you wanted to, we could just copy and paste it and put it right here. Okay? So this angle right here, this goes from the horizontal, what? Down. You see it? So from the horizontal down, so what angle would this be? This would be the what? Elevation or depression? It's going down, so this would be the angle of depression. All right? So another color here. So let's go from the boat. Now I didn't do that yellow very well. Let's take it to there. That's a little bit better. That's what I should have done. Let's change colors. All right. What about, there's another angle. It's the angle from the boat to the person on the cliff. All right. And this angle goes what? From the horizontal up to the line of sight. You see it? So when you go from the horizontal up, this would be the angle of what? Elevation. right? So it's always in reference to the horizontal. So if I'm looking this way and I'm looking down at a spot, that's my angle of depression. Or if I'm down below and I'm looking up to the cliff, okay, that would be the angle of elevation. Everybody see that? What do you think is true about the angle of elevation and the angle of depression? Look, these are parallel. Agreed? Because they're both horizontal, right? What's true about them? They're the same. Because of, any idea? It's been a long time since we talked about this. I got parallel lines cut by transversal. What is this angle and this angle? Remember that? It's not opposite. It starts with A. Alternate interior angles, okay? So it's coming back, all right? So alternate interior angles. So this angle and this angle are equal to each other. So basically, the angle of elevation is what to the angle of depression? They're equal to each other, all right? So that's kind of what we're talking about here. We got it? So what they're going to do is I know you're going to hate this, but they're going to give you some word problems. They'll give you some pictures, all right? And that's what they're going to do. So example 5, I don't have time to do all of example 5, but I'll at least get it set up. It's saying there's an airplane. Here's my airplane right there. All right, it's flying. Here's the ground. And we're assuming that the airplane, I have to make a lot of assumptions here, but we're assuming the airplane is flying parallel to the ground. Okay? You with me on this? Then there's a mountaintop. There's a mountain right there. Here's the snow-capped mountain. Okay? And the problem says that the elevation, not the angle of elevation, but the elevation or the altitude probably be a better word, of the airplane, and they tell you what it is. It's 7,000 feet. 7,000 feet. So that line right there would be 7,000. And they tell you the angle of depression is 7.5 degrees. So what does that mean? We'll go to the top of the plane. Okay? So there's your angle. There's your line of sight to the top of the, I said top of the plane, the top of the mountain. Okay? So let's draw a horizontal, just so we have a frame of reference. And let's draw another horizontal. Just copy and paste that. Put that right here. Like that. Okay? So here's all the stuff that they're telling you. They're telling you that the angle of elevation, or angle of depression, is 7.5 degrees. So that's 7.5 degrees. That's your angle of depression, right? From the horizontal down to the line of sight. Give me a second. And then they ask you, they tell you how far from the airplane horizontally to the top of the mountain. So they're telling you see that? If I drop this down to there, they tell you that this is 2,400 feet. So they tell you that they're 2,400 feet away from the top of that mountain. Not this way, but going this way. The question is, how tall is this mountain? Okay, that's what you want to find out. How tall is the mountain? Well, here's what you're going to do really quick. Let's find this. How are we going to find this? Look, I've got an angle, I've got opposite, I've got what? Adjacent. So I'm going to do the tangent, right? I'm going to do the tangent of 7.5 equals x over 2,400. Solve for x, and when I solve for x, I get 316 feet. Is that how tall the mountain is? No, it's just from the top of the plane to the top of the mountain. Okay, how do we find the whole entire mountain? From here to here is 7,000. That's right. We take, now this is not drawn to scale, obviously, but it's 7,000 minus 316, and you'll get 6684. So that's the kind of stuff that you're doing, all right? That's what you're going to be doing, and that's how you actually use trig functions for a practical reason, all right? So your homework is on the paper.
This was the homework.
It's, yeah, let me have 1 to 15.
No,
And
it's 19 to 38.
oh, that was 12-1? That was 12. Okay, so I haven't collected 12-1 yet? All right, turn that in. And then 12-2 is 16 to 23. All right, so you're doing numbers 16 right there. to 23 tonight from sections 12 2. Everybody got that? All right.